Okay, and now we are going to study some basic concepts of stress and strain. First of all, we assume that the distribution of material is uniform. That means there is no discontinuity of atoms. Now, topics we will be covering are stress tensors, equilibrium equations, Morse circle, strain tensors, and constitutive relation between stress and strain. Now, what is the stress? Stress is nothing but force per unit area. Let's say we have a body in which force W is acting in normal direction. Now we have to calculate the stress on the top surface. So stress will be W upon A into B, which is the surface area of that plane. And now strain. Strain is the change in the length per unit length. Stress and strain can be related by this formula: epsilon equal to sigma by E, where E is the Young's modulus. Okay, now let's move to the stress tensor. The stress state at a point can be represented by an infinitesimal cube with 3 stress components on each of its 6 sides. Since each point in the body is under static equilibrium, that means there is no net force in. So only 9 stress components from 3 planes are needed to describe the stress state at a point. These 9 components can be organized into the matrix. This grouping of the 9 stress component is known as the stress tensor, which is, if stress is if stress is in one direction is negligible, then the stress is called as plane stress. Now, principal stresses. If we find a plane where there is no shear stress, then these stresses are called as principal stresses. The roots of this equation will be principal stresses, which can be obtained with the help of I1, I2 and I3. These I1, I2 and I3 are invariants which can be given by the given equations. Now move to the stress transformation. A very convenient method for this is Morse circle. The center of the circle is sigma x plus sigma y by 2, and the radius is square root of sigma x minus sigma y2 whole square plus tau xy whole square. And now these are the equilibrium equations. If body is in equilibrium, these equation will also always be valid. It is mentioned that the above equation can be combined to get an equation for a circle in terms of sigma x and sigma y. This circle is called as Morse circle. Morse circle can also be applied in 3-dimensional stresses. Morse circle can be constructed using these steps, which are given: steps 1, step 2, step 3, step 4 and step 5. Now move on to strain. There are 2 strain and engineering strain, which are equal for small strains, but for large strain these may be differ. Similar to stress tensor, strain tensor is also defined. Now these are some formulas based on Hooke's law which relate elastic strain and stress. There are some constants which are required for calculations, E, G and nu. Hence with the help of these relations we can relate stress with strain. Okay, thank you.